lovely day.
Oh, hi! Welcome to Le Chatelier's Manor. Come on in. Mr. Le Chatelier will be with you in a minute. You can wait here in the meantime.
Alright. I wonder where Grandpa Le Chatelier is.
Yeah, why is he taking so long?
Oh, look who it is, isn't it? Sammy and Tammy, my two favorite grandchildren. Oh, hold on a second, children. I need to go grab my keys. I have a little surprise for you all.
Okay.
Tammy, look what I found!
Oh, what did you find?
Look at all his awards.
Ooh, what are they for?
Le Chatelier's principal?
Wait a minute, I think I learned about that in school. Crazy.
Girls, come on in for a drink.
Alright.
Okay.
Why don't you both take a seat?
Alright.
Okay.
So I prepared 2 drinks for you. They're very yummy. I'm sure you'll love them.
What is it?
Well, you'll see when you drink it.
Why is it so cloudy?
Sammy, just drink it.
Oh my god, what was that?
Why did you make us drink that?
Well, I saw you both looking at my award back there, so it was salt water. Thought I'd teach you 2 a little lesson.
Why'd you give us salt water though?
You'll find out. Would you like to learn?
Sure.
Now, children, you must be wondering, why did I make you drink salt water? Good question. I saw you looking at my awards a few minutes ago, and well, it was about my principle. My principle mostly involves equilibrium. Now, what is equilibrium? Well, it's achieving the right balance between reactants and products. So I just fed you salt water. Do you know how you would obtain, well, normal water or a more diluted version of this salt water?
We're not sure.
Well, let me show you how it would be more pleasurable for your palate. So, we have this plain water, which we will pour into this bowl. Okay, and now let's put a little bit of salt in here. Let's say 1.5 teaspoons. Now we can do a molar calculation to figure out how much water we could use to dilute this, but I have already calculated this ahead of time. Sammy, could you come here and help your pawpaw out?
Of course.
Please hold this down, darling, while I pour in our plain water solution.
Like this?
Yes, perfect. Okay, now would you like to taste some?
Sure.
Sammy, Tammy, taste your water and tell me what you think.
Wow, it tastes a lot better, but why? Probably because the salt disappeared.
Wrong! That is not the reason. The reason is we have achieved the right amount of equilibrium between the normal water and the salt water, so it's diluted. The salt is still there, there's just an equal amount or the right amount to balance out the salt water. That's why you don't really taste the salt.
What?
Children, come with me. We must head to the outdoors, and maybe you'll get a new light of this equilibrium concept. Guys, let's go to the park.
Okay.
All right.
What is Grandpa doing? This is so embarrassing.
understanding of equilibrium. Ready
Okay.
to begin? So, remember yesterday there was a huge thunderstorm and all of you were complaining, but without that thunderstorm we would never have such a rapid current of the waterfall. So, this is how it works. See the immense body of water that is present in the river? Well, obviously there is not as much in the ditch. So to even the amount of water, since we have an excess of water from the rain yesterday here, we must get rid of some of that water and put it into the ditch. This will help establish equilibrium. Alright, so we saw the foolishness of my grandchildren. Let's take a look at the more educational aspect of this. Now, if we look at the equation below, we're going to see the effects of changing and increasing the amount of products and reactants that we have, and what effect will removing one of them have on the equilibrium. So suppose we increase one of the reactants like CO. Because there's an excess of CO, the reaction will shift towards the product side. Now suppose we increase the CH3OH, or the products, the reaction will shift towards the reactant side. Now suppose we remove something from the reaction, like CO, the reaction will shift towards that side to remove the change that occurs. Now let's look at the effect of temperature. So in the reaction below, it's an exothermic reaction and it produces 92 kilojoules per mole. So if we increase the temperature, we have an excess of heat on the product side. So the reaction must shift towards the reactant side to eliminate that change. If we remove some heat or decrease the temperature, the reaction will shift towards the product side to eliminate its effects. Now let's look at the effect of volume and pressure. Remember, volume and pressure are inversely related. So as you increase the volume, pressure decreases and vice versa. When there is a decrease in volume but an increase in pressure, the reaction will shift towards the side with fewer moles of gas. In this case, the products have 2 moles of gas, whereas the reactants have 4 moles of gas. So when we decrease the volume, the reaction will shift towards the product side. Now if we do the opposite and increase the volume, which means a decrease in pressure, the reaction will shift towards the reactant side, which has a greater amount of moles. Thanks for watching, guys. It's raining. I better head inside.
Con los terroristas. And do the Harlem Shake.
And I wonder where Stop it!
Children, where are you? Ah, the breeze is so lovely, children. Shall we get going now?